Now the last part of section 11.1 is the application of vectors. This is going to give you an idea of how and why we would ever want to work with vectors. Example here, vectors have many applications in physics and engineering. One example is force. A vector can be used to represent force because force has both magnitude and direction. If two or more forces are acting on an object, then the resultant force on the object is the vector sum of the vector forces. Here's an example. Two tugboats are pushing on an ocean liner as shown in this figure. Each boat is exerting a force of 400 pounds. What is the resultant force on the ocean liner? Now we have to look at this diagram to have an idea of how we can determine the components of the two forces and be able to add those together to find the resultant force. Now F1 you see is 400 pounds of force. That little tugboat is pushing on 400 pounds of force with an angle of 20 degrees above the positive x-axis. Now this is in degree mode, so make sure that if you're doing these on your calculator that you change the mode to degree mode. If the angle was given in radians, for example, if the angle is pi over 6 or something, you would want to make sure your calculator is in radian mode. So to find the horizontal and vertical components of the F1 vector, you're going to take the magnitude, which is going to be 400, times the cosine of the angle. That's your first component. And then the magnitude times the sine of the angle is your second component. That'll give you your two components for F1. Now, in the same way, you're going to look at F2. Also has a force of 400 pounds, but the angle is negative 20 degrees. So the horizontal component is 4 cosine of negative 20. The vertical component is 400 sine negative 20. We're going to add those two forces together to get the resultant force. In other words, how much total force is being applied to that ocean liner. Okay. So here's how we find F1. Again, it's the magnitude of 400 times the cosine of 20 degrees and sine of 20 degrees. And you can also write that using angle brackets or the unit vectors I and j. And then F2 is 400 cosine of negative 20 and sine of negative 20. And you can write those using I and j. Now the resultant force is going to be adding those two together. F1 plus F2. So if we take F1 plus F2, we're going to add the corresponding components, the i's and the j's together. And we get 800 cosine of 20 degrees, I, plus, well, when you add the j's together, this is a positive and this is a negative. Those are opposites, so we get a 0 for the j. So the resultant vector is 752I. What that means, the resultant force is approximately 752 pounds in the direction of the positive x-axis. Even though each tugboat is pushing with 400 pounds of force, the result is actually 752 pounds in the direction of the positive x-axis.